All right, in this video, we'll be talking about the concept of matrices in mathematics. Uh, let's start by defining matrices. What do we define a matrix as? Well, a matrix is a number or a symbol or an expression arranged in rows and columns to form a rectangular array. So if that looks so confusing, let me just break it down for you. We say a matrix is a rectangular array consisting of, number one, it's a rectangular array. Number two, it could consist of either a number, symbols, or expressions. And then the last one, it's arranged in rows and columns. This is the breakdown of the definition of matrices. So a matrix often contains either a number, a symbol, or an expression, and it's always going to form a rectangular array. Also, a matrix is always having two sections, the rows and the column. So we define matrix as a rectangular array consisting of numbers or symbols or expression arranged in rows and column. Now, there are some very important things you must never forget when talking about matrices. Number one is that you often define your matrix in capital letter. So one of the first things you should never forget is that you always write a matrix in capital letter. So we can have matrix A, matrix B, matrix C, matrix D, but everything will all be written in capital letter. Now, number two, what we have as a constituent of this rectangular array, which you can see an example right here, is often called the element of the matrix. So this is the matrix A right here. This is matrix A right here. And these are the various elements of matrix A given within this rectangular array. So we have, oftentimes, we often write the element in small letter. So you can see the constituent of matrix A is written in small letter. Now, the other thing I want to talk about, which is very essential, is the identification of the rows and column in matrices. It's very important that every student understand how to identify the rows and columns. Now, if you want to know the rows and know the columns in matrices, all you need to remember is that the rows is always the horizontal axis of the matrix, while the column is the vertical axis. What I mean by this is, you see right here, what we have right here is a row. You can see that is the horizontal. So that gives me row 1. This gives me row 1. So this is row 1, the first horizontal axis. This is row 2. And this will be row M, because you can see that this matrix, this is row M. You can see that this matrix was defined from row 1 to row M. And then from the next aspect is the column. The column is actually the vertical, as I said already. And in this place, you can see what you have right here. The first vertical column, the first vertical axis is what we will call column 1. And then the next one will be column 2. And the last one right here will be column N. All right, let's talk quickly about the order of a matrix. The order of a matrix simply often gives us the number of rows and columns of a matrix. It is always indicative of the dimension of a matrix, and it gives us the number of elements in a matrix. So look at the matrices we have in front of us right here. You can see we have a matrix A with the following element here, a matrix B with this element, and a matrix C with this element. Now, how do we define the order of this matrix? We said in order of a matrix gives us the rows and columns of a matrix. And don't forget, previously I explained to you that the horizontal always represents the rows and the vertical represents the column. So obviously here we have this as the first row, this as the second row, and this as the third row. So we have this first row, this second row, and this third row. This means we can clearly say we have 3 rows in matrix A. Now, we go on to the column. This is the vertical, the first vertical axis here. We'll call this column 1, and we call this column 2. So obviously right here we have 3 rows and 2 columns. So how we define the order of this matrix is quite simple. We just say this is a 3 by 2 matrix. So the order of this matrix is 3 by 2. Now let's go to matrix B. In matrix B we have this as the first row. This is row 1. We have this as row 2. We have 2 rows in matrix B. Whereas for the column, we have this as the first column. This is column 1. This as the second column, column 2. And this as column 3. So obviously here, we can call the order of this matrix to be a 2 by 3 matrix. Looking at matrix C has, we have this as row 1, and we have this as row 2, and we have only one column here, so we have just column 1. So right here we will call this a 2 by 1 matrix. It's very important to note that we often call the first is always the row and the second is the column. So if you are given the order of a matrix, you can obviously be able to deduce the row and the column. So right here, I know if I'm given a 2 by 3 matrix, if you write 2 by 3 for me, I know this matrix has 2 rows and 3 columns. Matrix C has 2 rows and 1 column, and matrix A has 3 rows and 2 columns. Now I want to also state one thing, that the order of a matrix, as I said earlier, it gives you the number of elements in a matrix. So from here you can, by knowing the order of a matrix, you can obviously tell what the number of elements in that matrix will be. All you have to do is to just multiply the number of rows with the number of columns. So obviously a 3 by 2 matrix will have a 3 times 2. So the number of elements here will be 3 times 2, which will be 6. So if you're given the order of a matrix, you can from there tell the number of elements, which you can obviously see. This is 1, 2, 3, 4, 5, 6. And then this obviously also will have a number of elements to be 2 times 3, which is obviously also 6. And then for matrix C, the number of elements there will be 2 times 1, which will be 2. So you can use the order of a matrix to always get the number of elements of that matrix. Alright, so I want you to go in the comment section and tell me the order of the following matrices you have right here. We can see matrix A, we can see matrix B, we can see matrix C. So go on in the comment section and give me the values for the order of this matrix. Thank you very much for joining. I hope to see you in the next video. Bye-bye.